Hello guys, it is my pleasure to welcome you to Recitation 8, and then we'll be looking at conservation of angular momentum. The problem says, while giving my carefully planned lecture on conservation of angular momentum, I spy on a student trying to sneak out the back. While seated on the chair, on my chair that is free to spin, I begin to spin my lasso over my head in a clockwise direction until it is making 2 revolutions per second. So we have the moment of inertia giving I of me as 2/5 capital M. I keep jamming this cable, sorry guys. This comes back. Okay, that's back. So we'll have 2/5 capital M R squared. So this is my mass, that's my radius. And I lasso as 3/2 small m r squared. Radius of lasso, mass of lasso, small m. So omega for lasso, omega lasso is 2 revolutions per second, 2 rev per second. Okay. So lasso is moving clockwise direction. While doing this, I also begin to spin. So here is some useful information. My mass is 20 times mass of lasso, so capital M is 20 small m. Okay. And that is a heavy rope, yeah. My average radius as I spin is 0.15 meters. So radius of me, 0.15 meters. So that's what they call R, the big R. And radius of lasso is the small r, is given to be 0.15 meters. 1 meters, 1.0 meters, sorry. Okay, good. So now this is the information we are given for the problem. Now let's see what they're asking us to do in this problem, okay? So the next slide says, what is the initial angular momentum of the system, me and my lasso? So initial angular momentum is I, me, initial angular me, plus I lasso, initial angular lasso. And this is 0 because before I started spinning, I was at rest with the lasso. So we both have no angular momentum because we had no angular velocity. And nothing was spinning, nothing was moving. So that's going to be 0 for question 1. Question 2, using moment of inertia as listed, what will be my spin rate in revolutions per second when the lasso is at speed? So when the lasso is at speed, as I'm spinning the lasso clockwise, I expect to spin counterclockwise so that I will balance the angular momentum I have started with the lasso. So what's going to happen is I lasso, omega lasso will be equals I me, omega me. So I lasso is given to be that 3/2 m r squared times omega lasso equals I me 2/5 capital M, which is 20 times small m r squared, then omega me. So I have everything except omega me. So this is 2 revolutions per second. Since they want the answer in revolutions per second, I'm going to leave this in revolutions per second. So here I have 3/2 times m cancel small m here times 1 squared times 2 revolutions per second equals 2/5 times 0.15 square times omega me. So I'm looking for omega me. Okay. So 2 takes away. Okay. So that equation will give us 3/2 is 1.5, that's 3 here, 3 times 5 divided by 2 times 20 times 0.15 square. Okay, that'll give us omega me in revolutions per second. Okay, in revolutions per second. Now, yeah, I forgot the 20 in the other part before, but we have the 20 there. So let's do this and see what it gives us. So 7.5. So do this, it just gives us 16.7 revolutions per second. Okay. So you didn't have to convert to revolutions per second first. Since you have revolutions per second on both sides, you can just keep revolutions per second. Okay, so 16.7 revolutions per second becomes omega m. So the next question says, what is the final angular momentum? So this is going to be the same angular momentum for the rope in the opposite direction. So it's going to be this minus that. So you're going to have 0 for the final, just the same way you had 0 for the initial. That's how the momentum is conserved. So your final angular momentum will be 0. And what direction do I spin? Of course, opposite the direction of the lasso. If the lasso is spinning clockwise, then you will be spinning counterclockwise. So that is the end for this recitation. I'll see you guys next week. Thank you.